Hello everyone, welcome back. So far we have learned a lot about singly linked list data structure. We learned about different operations we could perform on a singly linked list data structure. As the name implies, in a singly linked list data structure, there is only a single link between each node pointing to its next node only. That's why in a singly linked list data structure, only forward traversal or a unidirectional traversal is possible. We cannot traverse backward in a singly linked list data structure. In this video and subsequent video, we're going to talk about doubly linked list data structure. We'll talk about its advantages and disadvantages. We will also implement our own doubly linked list data structure and perform operations on a doubly linked list data structure. So basically, a doubly linked list is a type of linked list in which each node contains a reference to its next node as well as a reference to its previous node in the sequence. So talking about nodes of a singly linked list data structure, we saw a node in a singly linked list data structure is mainly made up of two ports: a data port to store the actual data and link port used to store the reference of the next node. But in a doubly linked list data structure, a node mainly has three ports besides storing the actual data. In a doubly linked list, say we want to store data here, we maintain this time two pointers: a pointer to the next node or next pointer. Also we maintain another pointer called previous pointer that points to the previous node of the current node. This allows for greater flexibility in navigating the linked list. Since we have two links, we can navigate both forward and backward in a doubly linked list data structure, but it comes with slightly increase in complexity of implementation of doubly linked list data structure. Also, it requires more memory since we are this time maintaining two pointers beside the actual data. So the memory overhead of a doubly linked list data structure is more than a singly linked list data structure. Say we want to store integer value, so an integer value will take 4 bytes. Besides storing this 4 bytes, we need to store a 4 byte memory for next node pointer, and we need to store 4 more bytes for previous pointer. So totally, beside each actual data for each node, we need 8 bytes of extra memory location. So one of the disadvantages of a doubly linked list data structure is increase in memory overhead. To represent a node of a doubly linked list in our program, we are going to use our node class definition. In our node class definition, we have a data port and one single pointer to the next node. This time we are going to add another pointer to point to its previous node. Say we want to call it prev or previous pointer. It stores the pointer to the previous node. When we create our node and we pass the data, this constructor is going to be called. We set the data to the data portion of the node, and we set the next pointer of the newly created node to point to null, and also we will set the previous pointer of the newly created node to point to null also. Say I want to represent the number 10, 20, 30, 40 using a doubly linked list. What I will do is first, when I create my linked list, I will maintain two pointers. Let's call it head pointer, initially pointing to null. Then I will maintain a tail pointer also to point to the last node of the linked list. Initially this is going to point to null also. Then to insert number 10, what I will do is I will create a doubly linked list node having three ports. Say I want to create this node. Initially the pointers of this node will point to null, and I will insert number 10. Say the memory manager allocated a memory address 600 to this node. Then I will make my head pointer and tail pointer both point to this newly created node. Since I have only one node in my linked list, so both head pointer and tail pointer points to this newly created node. Say I want to insert another node. I can create a node and insert the data number 20. Say this has memory address 100. What I can do is I will make the tail's next pointer point to the newly created node. In this case, tail.next will store memory address 600, is going to point this way, and I will have a pointer here, say new node. So this new node's previous pointer will point to the tail or its previous node. In this case, it's going to store memory address 600. This way we can create two links between each node. That's why it's called doubly linked list, since we have two links between each node. Say I want to insert another node or number 30, I can create a newly created node. So new node is going to point here now. Say I want to insert number 30, say it has a memory address 45. So new node's previous pointer is going to point to its previous node or the tail. Once we inserted the second node, we definitely increment our tail. Tail comes here. Then the new node's previous pointer is going to point to tail, which is memory address 600, and tail.next will point to the newly created node. In this case, memory address 45 is going to store memory address 45. And we definitely increment our tail pointer. Tail comes to the new node. This way, we can create two-way traversal between the items of a linked list data structure, a doubly linked list data structure. We can either traverse forward, we can also traverse backward between the nodes in a linked list data structure. If I have a pointer to a node in a doubly linked list data structure, say I have a temp pointer pointing to this node, using this temp pointer, I can take a look at the data of its next node. I can also take a look at the data of its previous node. That's why insertion is more easier in a doubly linked list data structure, because we don't have to maintain a previous pointer and loop through the linked list and to maintain a previous pointer and a temp pointer. Using one temp pointer, we can access the previous node and also the next node. Talking about disadvantages of a doubly linked list data structure, definitely it's going to be a little bit more complex implementing a doubly linked list data structure in compared to a singly linked list data structure, because this time for each operation we need to take care of the 2 pointers of each node. Also, in terms of memory requirement, it requires extra memory to store the 2 pointers. So in the next video, we'll see how to implement our own doubly linked list data structure using this node class. Thank you guys for watching, and see you in the next video. Please don't forget to subscribe to Code with Cougar for future videos. Bye bye.